My name is Vinayak Sathe. I'm a learner, continuous learner, having the growth mindset. And third thing is that I have been working in data and AI field last around 8-9 years. But I did my research while I was working on my master thesis. I used the neural networks, and my bachelor's, I used the natural language processing. Those time, 1993, I built using Turbo Prolog. You might be knowing, some of you might have worked at Turbo Prolog. Based on that, we built the NLP solution that time. But now, because of the GPU and other things, you have a lot more compute power, you have a lot many algorithms to play around, and you have a lot many business problems that everybody is interested to use this technology. My 20 years of experience and my observation through my everyday life and journey, from running around from the small village and watching the aeroplane flying over and mimicking that experience in my mind while running around. And when I first time sat in the aeroplane traveling from Mumbai to Singapore, I was thinking that what makes me here, like what is there that makes me valuable? What is there in this 2.5 or 3 inch space? What you accumulate knowledge, what you experience, and what are your application of that knowledge, what you makes the world better place or solving the problems. So my topic today is cognitive intelligence and NLP with AI. How many of you really recognized what is cognition? What is cognition means to you? I want to make this topic more interactive because it's a lunch session and I don't want to be dodgy. I want to make interesting for you. And at the end of the day, I want you to take away from this session and apply into day-to-day life. Not only you solve the problem or write a program and solution, but also you use it for yourself to build your better brain. Cognition is the mental action or process by you acquiring the knowledge and understanding through thought, experience, and senses. Now, these 3 words, thought, experience, and senses. As before this topic, Manju has touched upon the one thought. I am extending that. He said that machine learning and AI and all that we are still using the data. It's based on the child, how the child is learning, how the cognition is already there in the inside child, but it's learning the language, learning to abstracting things, learning to identify the things. How we can give this kind of power to the machines so that they can have this intelligence. So thought, experience, and senses. Experience, how it comes? By observing, watching, spending time, right? So experience you get over the period of time. You cannot get experience in one day. So same way in the evolution of these AI systems, or what we call intelligence systems, it evolved long time ago. Like first is Turing started in AI. He decided, okay, machine can answer something, machine can do something, find out the information. And later on, people evolved on that based on the different fuzzy logic, genetic algorithms, neural networks, and deep neural networks now, and then go on. And simultaneously, the third word is senses. Now, a lot of people here are having the senses, but are they using all the time? Are they here right now? Are their mind is always active and in the present, or using the information that senses is providing? That senses, so there are a lot of senses intelligence on that side, like the muscle memory we build over the period of time in our hands, or while playing sports or writing things, or just building that eyesight to pick up some small stuff we can, other people ignore. So can we give the machines this kind of intelligent senses? So all intelligence systems right now, everybody wants to put the AI into their system, so they want to make it intelligent, is based on somewhere they want to get the data, which is give them the insight and which gave them the extra edge over the other people who are not using that. So as we go, I'm building that as we go with the cognition, there is a cognitive science, which has been as a part of this NLP, natural language processing. You see that it comes around computational linguistic, knowledge engineering, and computer science. It's a combination of these three. The cognitive science, building this cognitive intelligence, your study of thought, learning, and mental organization, which draw the aspect of psychology, linguistics, philosophy, and computer modeling. Now, psychology, of course, because what is in your mind, thoughts, right? You solve the problem or you find a solution. So Einstein's famous thought experiments, he has solved the problem in the mind first, and from that it manifested outside. And then he built the mathematical models to solve the problems or understand the mystery around the world. So next is, I think, cognitive science, and after the science, you see that everybody goes to engineering and technology. Now, the computer science field is cognitive technology, which is generally, trying to mimic initially first the functions of the brain. Like, you see the microprocessor architecture. You have a ALU, you have a program counter, you have the memory, main memory, secondary memory, and your processor. All that things are our parts of the brain, different parts of the brain. Initially, it was a very rudimentary form, and later on, people try to build on that. So that all the natural language processing, data mining, pattern recognition, how the language, like our language, natural language, and the computer's language, like machine language, how it differs. So we got first natural language, and we created machine language or the assembly language or programming languages, the higher level programming languages, fourth generation, fifth generation. So all these build a technology called cognitive technology. Then it came recently now as the evolution or technology advancement with the cognitive computing. Now, there are companies like IBM, they come up with this chip called Synaptics, right? There are now, NVIDIA come up with the GPUs, which are very higher power, right? You can do the image processing in real time, the video processing. So as the power of the compute and we have the plethora of algorithms people build, because that now we have the power of computation. We have a memory which is affordable, which is not that expensive. People are using this artificial intelligence to use this cognitive computing and solve the different problems. If you see that the platform, there are various platforms, like for vision, you have for the human-computer interaction, dialogue narrative generation, and other so on and so forth. Now I use here words so and so forth. How many people you understand what I'm going to say next? Because I have just used the word so and so forth. Is the machine can do? Is the program can understand that? What I'm going to say next, so and so forth. So these are the things. If I give you the problem or to solve the maths, or if I ask you to write an essay or write a poem on certain topic, is a computer or machine can do that? We don't have those systems yet, that intelligence. Those will, into the next era or next phase, people are trying to mimic that human mind. But in the real sense, what stands apart between human being and computer is that cognition. And we can go to the next level, is cognitive intelligence. Now I come to my title, one half portion of my title here. What is a cognitive intelligence? It's what's going on in your brain. So I just touch upon that. If you want to solve some math problem or you want to write an essay, it comes from your own mind. It doesn't require anybody's help or any other data. But today's most of the AI-based systems, we need a data because they don't have experience. To give the experience, we have to give the information, data. And then we have to model it. We have to write algorithms so that it can organize the data. It can find the pattern from the data. So we solve the human problem by thinking, reasoning, and remembering. Now these three things are very important. How we can give the machines the ability to think, reason, and remember. Now remembering is, we have solved that problem pretty much, like we have a different kind of memories and we are doing the real-time caching, real-time analysis and all that stuff. But the thinking part is the one which without data or without having information can you think. So those are the cognitive intelligence we are trying to build in the systems, and there are a lot of platforms. You might have heard about IBM Watson, and you might have a Siri on your phone, or Cortana, or you have those systems are evolved over the period of time, because the audio is a three-dimension. It has a pitch, volume, and frequency. Same thing, what we think, what we dream, what you write, what you read, it in form of words. And those words, the text, it has two things. One is that it has a sound, it's a phonetics, and it has also a meaning. So based on that, the meaning and the sound, and then when you put words together, it forms sentence and it gives some context to you, so that you can understand, okay, what is the topic conversation going to have or going to have. So I'm moving to that next portion of my title is NLP, right? I think everybody knows NLP is natural language processing. There is another, long form for NLP is the neuro-linguistic programming. It is another technique people use in leadership to motivate the people and better organize their mind and brain. So natural language processing, now the AI part of this is that we are trying to make machines. I think Ranjan has gone through this a lot, but I want to touch these two things here. That when we think that artificial intelligence, it does try to do the human-like things, either a mediocre human being or intelligent human being, or the specific task the one human being is doing. We try to mimic that. Those automated tasks, right, use intelligence. Like there are two important key components AI offers. One is automation, another is intelligence. Now, this diagram, I will stay a little bit longer on these diagrams and explain you about this. Everybody can see this from the back. If I'm not sorry, I will read that. So there are two blocks. The top block is about automation, automated, and the second bottom line one is the intelligence. Now, if you see that these AI field, there are various different areas. We are now going to touch on this natural language processing NLP here, but there are other deterministic rules, process decisions, robotics, event processing, predictive knowledge management. And then you see that other part, the intelligence, where you have this machine learning. So we make the self-learning algorithms, the programs which can train themselves and become intelligent over a period of time. And there are different techniques we have for learning. We figured out that how we make these machines learning easy. So from this portion, I'm just touching upon the natural language processing. You see that text to speech, translation, speech to text, and then automated speech, automated writing. And then from here, if you use the deep learning and unsupervised learning, you have image recognition and you have image to text, right? Writing the captions for the picture. So you are using multimodal intelligence there. You are using the vision as well as you are using your ability to, express your thoughts through the words on that image. And then this is automated grouping. So you see things, automated speech, automated writing, and automated grouping or understanding. So these three things are the essential part of natural language processing. As I mentioned earlier that computational linguistics, knowledge engineering, and computer science, all three combined together, help this field to grow, the NLP, natural language processing. Now, one of the goals, that I skipped this slide because we covered that. Now, these are the stages as I was talking about the consciousness or cognitive mind, a cognition that Right now, we got this machine learning thing going. We have this set of algorithms. We know how to write this self-learning algorithms and all that. But we are trying to go to the next level, is that we are developing intelligence out of it. So we come up with these deep neural networks. Again, it's a mimicry of our brain. Our brain has billions of neurons. It uses the electrochemical action. It has a different synapse. It generates a different neuropath. It creates the neurocircuits, and it actually surrounds the neurocircuits with the fat to make it faster. And how you connect these different circuits together and different neurons together at a given point of time, you solve the problem. So there are a lot going on in our brain while you are listening this, because it's not my words, but your own thoughts, your own cognitions. You have a questions. You are verifying that. What is wrong? What is right? And the third part, we are at the second stage right now. In AI, we are at the second stage. The third part is machine consciousness. We are not yet there. See, we are self-learning experience without the need of external data. We are not there yet. So we are trying to do certain thing in that we are making the senses intelligent. That means we are identifying the sensors which are giving the data, which can generate data or have that kind of capability, but we are not there. So I think this Ranjan has covered these three types of AI, but I just want to focus on that where we are. This is artificial narrow intelligence, they call. It's a basic task, chatbots and personal assistants, Siri and Alexa, all those things are still the narrow intelligence. Means it's specific task. In a specific area, you are making that machine to be intelligent, to act like the human being. Now, after this, my session, Sagar is going to take you onto the practical aspects of that is chatbots. So he is going to do some labs with the chatbots. But I'm going to build the approach, how you solve that problem. Then there is a artificial general intelligence. In that area, there you see that self-driving cars, Uber, Tesla, they're doing that autopilot. So those are the things more of the generic task, because while driving, you have to do so many activities. It's not a one single task, multiple things you have to do. You have to use multiple senses to do that. So we are kind of, here, but we are not 100% there yet. And this is, I think, is far like next 10 years, 15 years is far, is because that's, I don't think that machine, we used to call earlier in the 90s, there was a word we used to use as machine intelligence rather than artificial intelligence, because there was a lot of debate on whether to use artificial intelligence or machine intelligence. Because really, the point I connected, that cognition or consciousness is not there in this machine intelligence or artificial intelligence, what you call. Now, these are the four things I think is covered quickly. I just want to refresh your mind that Ranjan has covered. And for my topic, I needed these 5 things to be understood clearly so that you can build on that. So AI is building system that can do intelligent things. NLP is building system that can understand language. So the word understand is very important, because without understanding, you cannot read, we cannot write something, or you cannot speak something, right? You have to understand what is the conversation going on. Otherwise, that is no relevance there. The third is machine learning. Now, you can learn from your experience. So you have a data, you have a tremendous sort of data, but that data has to be smart data. That has to be meaningful data. The data should not have a much higher percentage of noise. If you have more noise in the data, what will happen? Garbage in, garbage out. Your model will fail. You will not get the response. Either its model will underfit or overfit. If you make it too generalized, right? You will have a lot of outliers. So as a data scientist in science, when you work with the data, you do feature engineering, you develop model, and then you score the model, and you tune the model, and you do different models and race condition those models and find out the best optimal model for that particular data. But still, you don't know what data is coming next. So machine learning is evolving process. As Manju mentioned, that it's like teaching the small child, do things. It takes time. So experience a thing which you cannot achieve, over in one single day. It takes long journey. The Fourth one is the neural networks. So neural networks is the technique right now you use. It requires higher compute power. In those days, in 90s, when I was running my model, neural network, that's a 3-layer neural network, I used to take 1 week to train that model, the neural network, not backpropagation network. Now it's because of GPUs, and then you can do in minutes that same network. So you have seen, experienced that TensorFlow, right? How you play around, how you see that this is training the model and you're getting results. Then the fifth aspect is the deep learning. The deep learning is nothing but the same artificial neural networks, but it has a hidden layer, has a multiple. It's a depth of the hidden layer is higher. So you have a lot of layers in between. So those are used for the large set of data, especially for the image processing or the video processing, all that, the deep neural networks are required. So deep learning is the one which is taking you from the second layer, from the machine learning to machine intelligence side. Now, what is natural language processing? As you know, as I touched upon the computer languages or the human natural languages, you see that the title is very interesting because I was observing NLP is natural language processing, but we are using artificial intelligence. So we are using artificial intelligence to do that natural language processing. So now you see that there are a lot of products we are having that are getting it up to the perfection mark. Still, there are some scenarios they will not give the exact results what we are expected. So there are a lot of chaos happens, and it's all about data. It's all about training the model. It's all about selecting the right model. So when you go from the natural language processing, this is a little bit history that from where it came. I touch upon that. I will skip this side, but I would just want to touch on that. What are the parts? Like, it's a complex field. Natural language processing is a very complex field because if you see in English language, the dictionary, how many words you can think of in English language right now?
Typical person has about 100,000.
100,000. The total in English language with the dialects and other things, if you have,
4 million.
Yeah, and now if you see that how many languages we are having, and there are languages nowadays people are not using words, they're using emojis, they're using slangs, they're using so many things which are not even normal dictionary. Like you get it by having the cultural intelligence, having to be in that space, hanging around that period, you get that understanding about that word exactly. So it's getting very complex field, and it's the intersection of the AI, computer linguistics, and computer science. I touch upon that too. And there are two parts of the natural language processing. One is natural language understanding, another is natural language generations. So as I mentioned that you do everything in terms of words, right? You think. So natural language generation and natural language understanding. NLU is pretty comparatively easy. We solve that problem. There are a lot of companies having products in that space. They have a cloud-based services, the cognitive services. They have devices which they are putting the intelligent devices, and they're accessing that through the data. They're learning. But the NLG, natural language, generation. So if you want to write something, or you want machine to write something like essay or that, this is a very difficult problem, and it is the complexity much gets bigger and bigger in that space. So you have very few products in that space which actually can getting that closer to that. There is something called robo-journalism. How many people know about that in robo-journalism? There are products which browse through all the internet and gets the news, and then they generate news. And even while I read those news, I cannot differentiate. This is the generated by machine, or this is human being has written. Because it uses those cues of the emotions, it uses the cues expressiveness, use the punctuations exactly so that you can understand better. So in NLU use cases, like now in NLU, natural language understanding, the goal is that you get this unstructured data, and then you convert into that, translate, convert into the structured data and understand what is written. Because we have to organize data. We have to put these words together and make a context out of it and then understand. The general use cases you see that is a data discovery. You go thousands of pages of written documents. You can capture the data which you need. Then there are smart searches. There are companies who have done these searches and information retrieval and information extraction. That technology they have developed into the smart searches. There are knowledge engines are there. Decision engines are available. Then the third part is voice recognition. Now, there are two things. The voice recognition can recognize actually the voice of the person. Like it identifies this voice is yours or somebody else. Like speech recognition and voice recognition, the difference is that speech recognition only understands somebody has spoken or not. But voice recognition understands it is your voice or not. So if suppose you are in the background, there are different people are talking in the meeting, and you want to take a notes, like you want to write a program which take the meeting minutes and finds out that, okay, this person made this comment. In that case, you have to get that data, the audio, and you have to find out that this voice is for this person. That person has spoken there. So understanding the spoken word, that's now Siri and other that as this technology of voice recognition is improving, we are getting that too close. Like now Siri is understanding, okay, this information, this is the way that person talks, or that's the vocal cord of that person has these many parameters. So the frequency, pitch, and volume of that person is this way. Whether that person is human, male voice or female voice. So when I was growing that, I was doing the thesis that one of my professors has given that very interesting problem to us to solve. It was in the part of the digital signal processing, but it requires also the AI, neural networks. So the problem was that there was an old gramophone, and it has a two old singers, duet song. And the gramophones, one of the female song, the tracks were destroyed, so you're not able to hear. And he wants to replace that female singer's voice with the youngest female singer and make that duet song in sync. It was a very difficult problem that time. We have written so many bunch of digital filters. We have done a lot of signal conditioning because the human audible range is 20 hertz to 20 kilohertz, and then between that, how you identify the voice of the female is only based on the pitch of the voice. So I'm just quickly over these use cases. This convert information into data on the computer to understand, right? So NLG, the second part is more complex. I just mentioned that. That is how you make systems or intelligent system which can write for you. It can, advise somebody. It can develop some analytics out of that. So it has to have an understanding, plus it has to have its own thinking to, abstract certain things and generate the, information. So all the written reports, summaries, explanation, advice, or meeting minutes, this comes under that NLG category. These are the best use cases. You can find that. There are a lot of applications you see that. I had touched upon this, one of these robo-journalism, while I'm talking about to you that. And then analytics, there is this interesting application I found at ESOP Compose. So they are using this NLG at the next level to explain draw the insights. Like it is not like, what traditionally we do, but they are using this NLP, natural language processing techniques to do that. And you see maybe Manju might be interested in that too. There's a sales enablement and sales performance. Finding out the talking points, or writing the talking points from the meetings and memos inside the sales and salespeople. So that the problem of that we are not remembering things a lot, right? We are not in the present moment. We are always on the rush. Our life become very, very fast. So these kind of softwares will help you to take notes, draw the points what you want. We don't want to that entire garbage. We just want a few bullet points and move with it. Now, why the deep learning, is needed? Those in back days, we used to have I mentioned that Turbo Prolog, which we have to data dictionary. We have all the content which is organized into data dictionary, the structure format. And then you make a natural language query. It parses your sentence, subject, predicate. It parses the active verbs, passive verbs, active words, and generate the tree. And from the tree, it can make a query, SQL query to that structure and find out the answer. But now, we don't have this kind of structured data. Our data is more unstructured. We have the data all over the places. So deep learning gives ability to process that just like our brain while you are doodling something or you are listening to me. There are people who are doing multitasking. Still, in their mind, a lot of thoughts are coming and they're deducing from that, they're understanding. So the deep learning will help you to do that. The three main capabilities of deep learning: expressibility, trainability, and generalizability. There are others are there: interpretability, modularity, transferability, latency, and adversarial stability and security. But the top three main capabilities help you to develop these intelligent systems. And then here are, I think Ranjan has covered, but I am putting the NLP usage for those algorithms. So these are the algorithms which are used, deep learning algorithms used to solve the different problems or different capabilities you can give using NLP. So for example, if you see convolutional neural network, you have a sentence and text classification, spam detection. You can detect spams in your email. Then you have semantic, the relation extraction. You see a lot of these sentiment analysis. You'll see a lot of people are developed system of sentiment analysis. They use the recursive neural networks. For image capturing, if you see that they use the recurrent neural network. So all those different algorithms giving the capabilities to use solving the different problem in NLP space. There is another I classified based on the the automatic the information, the way you classify whether do you text analytics or text mining, or whether do the information extraction or the information retrieval from the web, or you can summarize that or do the sentiment analysis. These are the application I classified in the different groups based on the complexity and the techniques which you use. If I'm running out of time, but if I can take one example and explain you that how this can be done. So you see that when you take a sentence, first we have multiple sentences. You have to identify where the sentence starts and ends, and we get the sentence, and then you chop up the sentence into words. So sentence segmentation, and then you get that word segmentation, and from the word you have to see how the next words are coming together, and you get a context, right? So you have to understand the part of speech tagging, like sentiment analysis. You needed that. Then you can expand your query. You can parse that entire things together, and then you can find the topic of that. So get the context. So these are the different applications you can find out. You can do more research on that. If you are interested in a particular thing, we can talk after over the lunch. There are QA systems. There are a lot of dialogue systems are developed now. There are virtual assistant, personal assistant. You are having those. So it's a very vast field. As I was telling, it's very complex and it's a very vast field. People are doing the PhD only in particular areas like dialogue systems. They're writing only paper into that. So now here I was giving the touch upon how to approach if you have a problem, then how we do. These are steps we do in natural language processing, because you have to get the data in the right format. You have to identify the type of the data, and then you have to put together that and find out the context. So first I mentioned that in the sentence segmentation, then the tokenization is the word, and then stemming. Stemming is a different forms, like one word has a different form. So from that you can find that what is the actual word, what is the active verb involved in it. The part of speech you find out whether adverb or whether it's the verb. Then there's this parsing, right? You parse and you name entity recognition. Now this identify that location or the person or the time you give, and then co-reference to resolution. There is a lot of times, your previous sentence and next sentence. Like that's example I was giving, so and so forth, right? So and so forth is your previous sentences. You are trying to find out and interpolate that and finding out what is the next thing I'm going to say or I mean to say. The techniques we identified here, and how with the sample input you can find the output. Like suppose you segment sentence segmentation. Alan met the president. He said, "Hi!" exclamatory mark. "What's up, Corey?" Now all these punctuation mark, they also give the meaning to that. Now this sentence just here first divided two sentences, right? Based on the full stop, right? The period, identify these two sentences. Second thing, tokenization. Now you chop up each sentence into words and you find that word as different tokens. And you see that punctuation marks also are considered here. The third one is stemming or limitization. Now these three forms of eating, ate, eaten is also talk about only about eating. Then your part of speech tagging. So you have to tag that part of that each sentence, the word, to in language, whether it's a proposition or the personal pronoun or the verb noun, etc., etc. And then you do parsing. Now parsing is when you find out with building the parse tree here. So we are actually connecting different words and finding the meaning out of it. How these are correlated out that. And then the name entity recognition. Now you see that this sentence, let's meet Govind at 6 a.m. in India. Now in this, you see that person, time and location. These three things you are finding out. So your name entity, you are recognizing who is the person, what's the time and what's the location. And that gives you interesting insight. Then the last one is co-reference resolution. Now if you hear this first sentence, Alan went to the mall and he thought it was shopping mall. Now here you got the output as saying because this sentence, actually two sentences, has exactly co-references. So because he represents Alan and then malls, the specification of mall is shopping mall. So with this, I think I will stop here. I have some of the things, but these are the tools like people wants to play around. NLTK, Orange, Scikit, or Apache OpenNLP. I use this tool Stanford Core NLP also and Word2Vec. As a word, you can change over different words in the multiple vector spaces, and you can do multidimensional. You can actually get a better meaning out of it. Just I was mentioning that audio is the three-dimensional. Right? It has a pitch, frequency, and volume. Every word has a meaning and sound. With this, I think I have given just a seed of thought, here, that from the little child, which is learning to speak from a mother or mimicking the lip movement or the sound and developing the voice box of his own vocal cord, to when they become an adult, making the business decisions, $1 million decisions. How we have grown up that time, our machine learning also growing that way. Thank you very much, Alden.